This video contains 4 examples of proofs involving inequalities. To prove an inequality, normally we use the fact that the square of any number is never negative. Okay, example 1, prove that a squared plus b squared is greater than or equal to 2ab for all a and b elements of R. Well, what we do in this, firstly, if we take 2ab from both sides, we'll have a squared minus 2ab plus b squared is greater than equal to 0. But we might recognize this because you might remember that a minus b to b squared, if you expand that, you get a squared minus 2ab plus b squared. So we can rewrite the left-hand side as a minus b to b squared. But anything squared can't be negative, so it has to be greater than or equal to 0, which is true. Okay, in the second example, we have a is positive, b is positive, and we're trying to prove this inequality. But because a and b are positive, it's okay to multiply by them. So if we multiply everything by ab, it will get rid of a fraction, so we'll end up with a squared plus b squared is greater than or equal to 2ab. Again, we would take 2ab from both sides, so we have a squared minus 2ab plus b squared is greater than or equal to 0. And we should recognize this again, because if you expand a minus b to b squared, you get this result of a squared minus 2ab plus b squared. So the left-hand side is a minus b to b squared, and the square of a number cannot be negative, so the inequality is proven. In example 3, show that x squared plus 4x plus 6 is greater than 0, or positive. And this one is a little bit more tricky. What we do is we try to write this as a square of some sort. So we use the trick of completing the square. So we're asking ourselves to complete the square. What square begins with x squared plus 4x plus a number? Now the method I use to do this, we'll draw a little window. In the first pane of this window, we put in x squared. The factors of this are x and x. Now these two side ones must add up to 4x, and it must be the same thing, so we'd have 2x and 2x in each. So in other words, we multiply x by 2, so plus 2 is on the side, and then the remaining bit is 2 2's, which is 4. So x squared plus 4x plus 6 is the same as x plus 2 squared, and we need to add on 2. Now this is greater than 0 because obviously 2 is greater than 0 and any number squared is greater than 0. In example 4, we're to show that a plus b multiplied by 1 over a plus 1 over b is greater than or equal to 4. Now what we would do here is we'd expand it first, and we multiply it out. So if we multiply a by 1 over a, we get 1. A by 1 over b gives me a over b. B by 1 over a gives me b over a. And b by 1 over b gives me 1. And this is greater than or equal to 4. Now just neating this up, I have a 1 and a 1, and if which is 2, and I take 4 from both sides, I end up with minus 2. Now I'd rather not have fractions, so I multiply everything by ab. We know this, we can do this because a and b are positive. We end up with a squared plus b squared minus 2ab is greater than or equal to 0. And again, we should recognize this, that a minus b to b squared gives us this result of a squared minus 2ab plus b squared. So the left-hand side is a minus b to b squared. And that must be greater than or equal to 0, and that's true. So we've proven the inequality.